This is lesson 12b, the transformations of functions, part 2. So we're going to take what we learned on the last lesson and make sure we can apply it to everything we've learned so far in geometry, and then also some of the things we've learned in pre-calculus. Okay, so first let's start with a little review, and then we just have this table which has values from f of x, and we're going to create a new function by this looks like translating it and dilating it, making it stretch in different directions, right? So each of these three values, A, B, and C, are going to correspond to these three questions right here. So a horizontal dilation by a factor of 3. Recall that if it's horizontal, right, that's going to involve the x-axis, right? So that means it's going to be within the parentheses here. So that means for this part, a factor of 3, we're going to be working with and trying to find out b. So I want to write this out. G of x equals, I'm going to just leave the a alone for now, and ask myself if I'm going to stretch this by a dilation factor of 3, and it's inside the parentheses. Remember, we have to do 1/3, right? It's always the opposite when we're working with x's. So I'm going to make that a 1/3 x. And you can look back on the first page of the notes and, that explains all that as well. Actually, it's on the second page of the notes of this chapter. Let's see here. So we know that b is equal to 1/3. All right. Next, we can do a vertical dilation by a factor of 2. So vertical, right? Of course, that's going to be the y-axis. So we'll be working with the a value this time. So now g of x is going to have a stretch of 2. Right, and we have the rest of the equation. That's already good. And then c we'll do next. So now we know that a value is equal to 2. And then lastly, we have a vertical translation, right? That's going to be the last value of c, and that just moves it up 5. So finally we have 2 times f of 1/3 x, and this vertical translation just becomes a plus 5. All right, so lastly, find the value of g of -6. So I'm going to give myself a little bit of room because I don't want to squeeze this in a small space and accidentally make a mistake. I'm going to put this as equal to 5 over here. All right, some of the mistakes we made are not because of not knowing what we're doing, but just because we're trying to save space or not showing enough work. All right, so I'm just going to plug in x, which is -6. Okay. And then be very careful in showing the work as you go through to make sure you're not making any mistakes. So the first part is going to be to simplify the parentheses here. So 1/3 of -6, that's going to be -2. All right, and then we need to substitute. We actually need to know what the value of f of -2 is, right? And that'll be found right here. There's -2. So I'm going to substitute out f of -2 for 12. All right, so, and then lastly, we'll have 2 times 12, which is 24, plus 5, which is 29. All right, So of our new function that has all these transformations and dilations, -6 maps to 29. Notice how that's not this graph, because this is a chart of f of x. We're working with a new function, g of x, in case you're wondering why this doesn't match. All right, let's move on down and just do a little bit of review of our domain and range and translating. Just recall, what does the function do when we have a x plus 2 inside, right? So that is going to be, that plus 2 is going to make our graph move. Which direction? Is it left or right? Right, so yeah, this is going to move the graph 2 to the left. So x minus 2 for the coordinate. And then what will this -3 do? Right, that will move the y-coordinate down 3. Just move them to the left 2 and down 3. All right, so looks like this one right here was at -4, comma, let's see here, at positive 1. So I need to go left 2, right? So that's negative 6, down 3, and negative 2. So negative 6, negative 2. Right there. And then down here, right, this is going to be, again, let's see, we got negative 2, comma, negative 1. So subtract 2, it's going to become negative 4 and negative 4. And this one is just 1 over from it, so I'm just going to actually move, I'm just going to know that that's just going to be 1 over. Okay, and then right here we have 1 comma 1 on this graph, so I'm going to subtract 2, it's negative 1, subtract 3, negative 2, negative 1, negative 2. Then up here we'll have, looks like 2 comma 3. Subtract 2, subtract 3, that's going to be 0, 0. Right, and I'm going to use a little bit of symmetry here. I know this is going to go up, come back down, so I'm just going to go up and come back down. And this one goes down 1 over 1, right? I'm going to go down 1 over 1 as well. So since these are on different scales, it wasn't just an easy, slide it over, but we could still know that these two transformations keep the shape the same exact size, right? So it's called a rigid transformation. So I know that before I even started that it's going to be the exact same shape. It's not going to be stretched out or anything, but because we're on a different scale on the right-hand side, just wanted to be very careful about that. Let's see here. Go, and there we go. Okay. All right, next, did we answer everything? Oh, part B, state the domain and range. Okay, so our starting domain was negative 4 to positive 4. So let's go, no, that's not going to work. So we had domain to start with. It was negative 4 to positive 4. And because our rule was to subtract 2, right? Because we had x minus 2, we just subtract 2 to each one of these. So our new domain is actually going to be negative 6 to positive 2. And we can check this on the graph. It does start at negative 6 right here, and it does finish at positive 2. So we can both do this graphically and analytically with just using the numbers. All right, and the range, let's do the range next, which is not given to us. Okay, so we can get the range off of here. It's negative 1 to, let's see here, negative 1 is the lowest point, and the highest point is 3. So our range is negative 1 to positive 3, and then we subtracted 3, so we did y minus 3, so I'm going to do minus 3 and minus 3. So it looks like we have negative 4 to 0. And we can double check that here. Yep, the lowest point is negative 4, highest point is at 0. Perfect. All right, let's carry on. All right, so for example 9, we have a function that's not really given to us. And then it says in the xy plane, which we work with, h is created by a sequence of transformations. Okay, so we have a vertical h as a result of vertical dilation, right, by a factor of a half. Okay, then dilating horizontally by a factor of a third, and then translating horizontally to the left by a factor of 7, and finally translating vertically 3 units down. Okay, so we got a lot going on, but this is basically what we did earlier right here. It's just giving you more information. There's, I think, looks like there's A, B, C, and there's going to be a D as well. But it's really just piecing together all that information and coming up with a function. We just don't have know what the table is, but basically the same type of problem. We just won't be able to find any values at the end. Okay, so just break it down one by one and what they each mean. I'm going to do some highlighting. All right, so we have a function, right? We have a vertical dilation right here by a factor of a half, right? And we have a horizontal dilation by a factor of a third. And then we're going to translate horizontally to the left 7 units. And then lastly, we're going to translate 3 units down. All right, so let me draw a generic equation like we had before. So we have this h of x. That's what we're working with. And like that first problem, we had a and we had f of x. I think we had a b here, right? X. And then we had a c on the outside. So we had 3 things to find on the first one, but let's see what we got so far. So this vertical dilation by a factor of a half. All right, so which of these 3 will do that? All right, that's going to be right here, A. And then we have a horizontal dilation of factor of 1/3. So it's a horizontal, so that's on the inside. And we're going to translate horizontally to the left. Now also horizontally to the left. So we are going to have a new parameter. Since it's horizontal, it has to be inside the parentheses. I'm going to call that D. I'm going to make this D. Okay. And I'm going to put this in parentheses as well. Okay. And this one, this horizontal translation in here, well, no, to the left, so that's going to be that D value. Okay. And lastly, we're going to have the vertical translation down. That is going to be the C value. So notice how before I just started putting it all together, I really made sure I know which of these pieces goes where. It's going to make this a lot easier having this structure. So now I can go through and actually put the values in, and I got to put them in correctly. So all the y values outside of the parentheses, those are going to stay the same. So like this 1/2, right, that's going to stay the same. And I know 3 down, that's going to be -3. I just have to be careful on the inside of the parentheses that I change them. So a factor of 1/3 on the inside of the parentheses is a 3. Okay, and then we're going to move, let's see, we're going to move to the left 7 units. So that's going to be x plus 7. Okay, so always being careful that on the inside of the parentheses, we actually change them around. Outside the parentheses, keep them the same. Okay, not too bad if we take the time to plan a little bit. So let's move down to here, number 10. So we have a function, and they actually give us an equation this time. Okay, so we have an equation, and we're going to do some more. We're going to do some more transformations here, just like we just did. It looks like there's only 2 of them. So let's figure out what they are first. So we're going to do a vertical dilation, factor of 1/2, right? So very similar to what we just did here. We did a vertical dilation of factor of 1/2. So we already kind of know what that's going to look like. And we're going to do a vertical translation down 10 units, right? So that's going to be very similar to this. This is down 3 units, so we know it's just going to be a number out here. And that's pretty much it. So nothing going on inside, which makes it really nice. So we're just going to have f of x. Okay. All right, so I'm going to have an equation for g. So g of x, right, it's going to be 1/2 f of x, and then minus 10. Okay, and it says, what is the new equation here? What is the new equation? So since we actually have an equation here, we know f of x equals this. So I am going to substitute, I am going to highlight this entire part. I'm going to replace it with f of x. So I'm going to have 1/2 parentheses and substitute in what f of x equals, the equation. It's 2x squared plus 6x plus 10, and then subtract plus 8, and then subtract the 10. And just clean this up. Let's just do a little distributive property and simplify this as much as possible. So I'll have x squared plus 3x plus 4 after taking half of everything, and then I got my minus 10. So one more step, I'll have x squared plus 3x, and that will equal what? -6. All right. Now, I urge you, go into Desmos and type in f of x equals this, type in g of x equals this, right? And it'll give you a graph, and then go down here, type in this equation. It should be the exact same graph, right? So you can prove to yourself all your work is correct. All right, let's go down to number 11. It says, a partially completed tables of the values represent functions g of x and h of x such that, and here's the relationship between them. Find the missing values in the tables. Okay, this is these could be a little tricky sometimes, but sometimes just a little trial and error will get us there. So we have to use the values that are given to us to find the values that are missing, right? So for instance, if I know I'm missing what g of 0 equals, it's a good idea to start with h of 0. Right? That's going to give us our information. So that's how do you know where to start? So let's start there. And it'll make more sense once we start doing this. Let's see here. Let's do blue. All right, so what I'm going to do is that I know h of 0 equals 9. Okay, so h of 0, I know that to equal 9. So that means, according to this function, this whole thing right here will be equal to 9. If I just plug in 0. That's a 9. Okay. So I plugged in 0 for both x's, right? And then I can simplify this. So I have 9 equals 4 times g of 2 times 0, which is g of 0, minus 3. So now what we're doing is that we're solving for g of 0. I don't know what it equals, right? That's what we're trying to find out. So think of this as the variable. So I want to get everything else away from g of 0. So just like solve an equation, you want to think about it like you're solving this equation. 4x minus 3, right? And do the same steps to get x by itself. We're just trying to get g of 0 by itself. So I'm going to add 3 to both sides. And I'll have 12 equals 4 times g of 0. And then, of course, divide both sides by 4. So 3 equals g of 0. So now I know that g of 0 equals 3. Okay. Now, there may not be a necessary order you have to go in. It's not about getting lucky, but you can kind of plan out, well, what can I use next that might help? You might have to think about this for a moment. So take a moment, pause, and ask yourself, what would be another good value to try to find find what is missing? So I'm looking at this. I'm seeing how this 1 and 2, that could help us out. So I want to try to work with this over here. I'm going to do h of 1, right, which I know equals 2. And that's going to be the same as 4 times g of 2 minus 3. Right? So I kind of worked out knowing that I need to find a g of 2, so what can I plug into h to get me a 2? And that'd just be a 1. I get 1 times 2, right? That's it. So I can, again, work backwards here. So I'm going to add 3 to both sides and get 5 equals 4 times g of 2, and divide both sides by 4. 5 over 4 equals g over 2, g of 2. So I know this is 5/4. All right. Can you find out what the next one is? We need to find what h of 3 is and what h of 4 is. All right, so I'm going to next work with this h of 3. And I know it's going to work because when I plug 3 into here, it's going to double it. And I'll need to know what g of 6 is. And I know g of 6 equals -2. So I can kind of already map that out, how that's going to work. And I could also find this one next as well. I could plug 4 into here, right? That'd be g of 8, and I know what g of 8 equals. So I can do either of these in either order. So it's not really specific to do it in the right order, just as long as you do it one by one. So we're going to have, let's do h of 3, which I know equals 4. No, I don't know that. I know h of 3. I'm going to plug in, plug that into here. So 3 in here and 3 into here. So that's going to equal 4 times g of 2 times 3 minus 3. So h of 3 is what I'm actually solving for this time. So I'll have 4 times g of 6 minus 3. I'll have g of 6, which I can get from over here. That's -2. And we'll have -8 minus 3, which is -11. So I know that this is -11 right here. All right, and if you haven't already, try one of these on your own. Do the last one on your own, see if you can put it together. All right, so we're going to do the same idea as this one. I'm going to use h of 4 this time. Don't know what it is, so I'm just plugging 4 into here. It's going to be 4 times 2 times 4. 4 times 2 times 4 minus 3, which of course is going to be 4 times g of 8. And g of 8 we know is -1, so it's going to be 4 times -1 minus 3. Give us an answer of, what is that, -7. Yeah, -7. There we go. All right, so these can be a little bit challenging. I urge you to stop the video and go back and see, make sure you can follow these and make sure they make sense. If not, put a star next to it, ask a question about it tomorrow. Okay, but don't just write it down and move on. We got to make sure we understand this stuff. All right, let's keep going. We're going to do, finally, we're going to apply some of this stuff, and we're going to do some translations with rational functions, not just lines and curves and parabolas, but the stuff that we've been learning in pre-calculus, because it works for all of it. Okay? So there'll be some slight differences, but nothing that we can't adjust to. And we're also going to do the domain and range. So it says first, write an equation of the rational function. So we have to have a general understanding already of what 1 over x looks like. So 1 over x goes right down the middle with both asymptotes. Okay, it looks just like this. All right. So we have to know that to start off. It's kind of like knowing what x squared looks like. Then we can understand how it's moving left, right, up, and down. So compared to what's on the page here, right, we can see that it's really just moved over 2 to the left, right? So usually this is on 0 with 1 over x. It just moved over, so that just changes the graph a little bit. And since we're moving in x direction, instead of having just x, we're going to have an x, and it's going to be a plus 2. So this is 1 over x plus 2 is our function. Notice how it's a different sign because it's involving x, right? So that's the equation that we have. That's f of x. And the domain and range, that's just going to be pretty much everything except for the asymptotes here, right? So it's going to be everything on the domain except for -2, and everything on the range except for 0. So I'm going to write like this. I'm just going to do domain, everything except -2. All right, so that would be this. Everything but the asymptote. And then for the domain, it's going to for the range, it's going to be everything but the 0 asymptote. So same idea, just using 0 instead of -2. Positive, yeah, not negative. Positive, there we go. All right. All right, it says here, use the grid to sketch the graph of G as the transformation of F. So we're going to take a new function, and looks like we're going to move it, let's see here, we're going to move it to the right, we're going to move it up, and then we're also going to stretch it, and we're going to reflect it. So we got 4 things going on. We're going to stretch it a factor of 2, and we're going to reflect it over the x-axis. So there's a lot going on here. So you got to be very careful. All right. So it's okay. Okay. Well, part C actually is exactly that. So let's do that. So I'm gonna type this out just to save a little time. So we're gonna have a vertical dilation of a factor of 2. We're going to reflect across the x-axis. We're going to do a horizontal translation of 4. And I'm going to say 4 to the right. And then we're going to do a vertical translation of 3 down. Okay. So let's actually make this that color, and what we're going to do is go through and just highlight these and match them up, make it a little more obvious. So my vertical dilation right here, right, that comes from this 2. My reflection across the x-axis, that's coming from the negative. And we have the horizontal translation, right? That's going to be this -4. And then we also have the vertical translation down. Oh, that's actually going to be up. Glad I got that. That's +3. Should be up. Very good. Okay, so we just have to put all that together in a graph. Now, you can do these in different orders, but it's a good idea to first realize where your asymptotes are going to be first, and then worry about the rest of it. Okay, so we have my original function, which is, so my original asymptote started here at, let's see here, they started right here, right, at -2, 0. And I'm going to translate horizontally 4 to the right and then 3 up. So from that point, I'm going to go 4 to the right, +2, and 3 up. And that way I know exactly where my asymptotes are and put those in first. All right. Next, I'm going to consider the reflection. Okay, next, I'm going to consider this reflection. So I know this is the original, so reflection, I know that the graph will be up here and down here. And then I just have to stretch it and make it twice as much, okay? So when you stretch it, you end up getting closer, a little bit closer to the asymptotes, and it shoots up a little bit later. So normally it kind of looks like this, and when you stretch it a factor of 2, it just gets a little bit closer. And we're only going to estimate this. We're not going to calculate these and be too precise. But just know the general behavior, like that normal will just kind of be like this. But if we increase everything, it just gets a little bit closer to the asymptotes. Never, of course, goes across it, though. All right, so that's going to be good enough for what we're doing. Okay, don't have to worry about the exact like x-intercepts or anything like that. All right, and then it says, lastly, state the domain and range. Okay, just like we did up here, we can do that again. It's just going to be everything but the asymptote of that axis. So for the range, domain, we can't have positive 2. So it's almost going to look like the same as this, but with positive 2's. And then the range is going to have everything but 3. So it's going to look like this, but instead of 0, you have 3's. All right, so we have the domain. Let's do it like this again. So I'll have negative 2, negative 8, and 8, negative infinity to 2. Oh, again, tired. And then we're going to have 2 to infinity. And then for the range, we're going to have negative infinity to 3. And 3 to infinity. All right, perfect. So again, taking our time to actually highlight and or at least think about, what's affecting what on the graph and doing one thing at a time. And it really goes a long distance, to have this plan ahead of time, as opposed to just looking at this and then just starting to try to graph it one by one. We really have to think about everything all at once. All right, here we go. Let's go down to here. So we're going to look at some more translating of these rational functions. Just notice how it's very similar to what we've done before, right? But we have the translations on the bottom for the horizontal part, right? So otherwise, everything is exactly the same. So we can actually tell what these are, right? So these H's and the moving left and right, that's going to affect the vertical asymptotes. And the number on the right-hand side, right, the moving up and down, that's going to affect the horizontal asymptotes, right? And we can confirm that back here, right? When we moved left and right, translated left and right, that moved our vertical asymptote, right? So moving left and right changes the vertical asymptote. Because you might look at this and say, well, if I move it horizontal, does that change the horizontal asymptote? And it doesn't. Same thing here. If we move up 3, we went from here to here, that changed the horizontal. So the vertical translation changes the horizontal asymptote. Okay, just in case you're looking at that and it seems a little off. So if we have this right here, and have a minus 3, that's going to make a vertical asymptote of positive 3. And if there's no number here, just think of it as 0. So our horizontal is going to be 0. All right, with that information, if you want to try some of these on your own, you can, but they're pretty straightforward. So whatever makes the value of the denominator 0, right? That's what a vertical asymptote is. It's dividing by 0, which is undefined, which is why you have these dotted lines, because there's nothing to graph. It's undefined there. So what makes this equal to 0 on the bottom? Negative 4. And then our vertical will just be, our horizontal will just be that number on the end. So we can actually do these pretty fast. Let's just do, and you'll notice this is written in a different order, which is fine. So we have y equals 4. Here we'll have what makes the denominator 0, just x equals 5, right? 5 minus 5 is 0. What makes the denominator 0? That's just 12. Nothing more than that. All right, so we went over quite a bit, but again, take a moment to rehearse or go back over anything that didn't make sense. Put a star next to it. Highlight it a certain color just to know you can ask a question on it later. Okay? All right, have a good one.